A fire is sighted due west of lookout A. Oh no. Fire. Okay, fire west of A. The bearing of the fire from lookout B, 8.6 miles due south of A. So I'll stop there for a second. 8.6 miles due south of A. Okay, so I put B right underneath A because it said due south, and I labeled that side length 8.6. Now let's continue interpreting. Is north 42 degrees, 26 minutes west. So there's two ways to express bearing. You can express bearing simply as a number, clockwise from north. And I already told you about that. That's very common. Or you can express it in this more explicit fashion where they tell you a starting direction, in this case north, it could be south. Then they tell you a degree measure, and then they tell you a terminating direction, west. So it's actually easier when they express bearing this way. So the second way is north or south, then degree measure, and then east or west. And hopefully you'll get enough practice to completely understand that. So back to this problem. The bearing of the fire from lookout B, so here's our reference point, lookout B, is north, so that's pointing up, 42 degrees, 26 minutes west. So I want to go west from north. (42.26). And there is your right triangle. Remember, the fire is due west of A, so that allows me to put a horizontal line there. Once you have your right triangle, it's typically easy from that point, because then you're just using Pythagorean theorem or SOHCAHTOA. Usually the hardest part is drawing the diagram, interpreting the words. We want to find how far the fire is from B. Easy. Here's the fire, here's B. That's your unknown. Think about which trig function would be appropriate here. Cosine, excellent, because you have adjacent to the angle, and that's not the hypotenuse and the hypotenuse. So a function that relates those two is cosine. Cosine 42 degrees, 26 minutes is equal to adjacent side, 8.6, over hypotenuse side, unknown. So we've done many problems like this. I think that you're fluent at this stage in solving these. So when you do the algebra, you find that the x and the cosine just swap positions. And let's get a calculator. I should be in degree mode. I am. 8.6 divided by cos 42 plus 26/60. I don't use the minute sign because I can type this way in faster. But feel free to use the degrees and the minutes sign that's in the angle menu, second apps. So it looks like the fire is about 11.7 miles from lookout B. This is one of the things that people use trig for, to determine the locations of things. It's called triangulation or trilateralization. And that's essentially how GPS works. If it wasn't for trig, there would be no GPS. (11.7 miles is the distance from the fire. You know what show that's from? I don't expect you to know because that's from my childhood. Beavis and Butthead. I think I lost several IQ points from watching that show in my adolescence. Any questions on number 1? Very well. Number 2. Let's ask a random person. Randomeister. Dominique. Tell me how to draw the triangle here, please.
Draw y and then a line to x, and then divide 85
Okay. City X is 85 miles due south of City Y. That means it's underneath City Y.
And then the west of x, we put z, which is 15 miles.
Very good. West of X is Z. And that's 15 miles. This is 85 miles. So this is obviously not to scale. Good, and then this has to be the hypotenuse. There's your right angle, because this is a north-south line, this is an east-west line. We are interested in the bearing of city Z from city Y. So, Dominique, which angle here am I interested in? This one? Here is the hint. Look at the from clause. From city Y. That's your reference point. So you're at city Y, you're looking at city Z. So to help us find the answer, we need to find this angle here. You can call it angle Y. Okay. Thank you. And Celine, can you tell me what trig function I can use to solve for this angle? Tangent of Y. Very good. Equals 15 over 85. And then how do I get to Y? Excellent. I'm impressed. Anytime you want to find an angle in trig, I would say use an inverse trig function. Second tangent in this case of 15 over 85. You're undoing tangent. And when you undo tangent, you get 10. That's an angle. It's in degrees because my calculator is in degree mode. No need for protractor. No need for ruler. This would not be the correct answer using the convention that we use, because if you told somebody who knows bearing that the bearing is 10 degrees, they are going to interpret that as 10 degrees east of north, and that's not the direction that you're looking. As you can see, you're looking southwest. So, not too hard to account for that fact. Remember, there's two ways of expressing bearing, and they're not dictating to you which way in this problem. So I'll give you both answers. You could say south 10 degrees west. That would be acceptable in my book. Or you could use the convention that starts from north, 0 degrees. So south would be how many degrees, anyone? 180. And then you're going 10 more, 190. Any questions on 2? All right. 3. Now we have speed. Not a problem. We can handle it. Speed and time can be mixed together to get distance. Distance equals rate times time, right? Totes. I love that formula. Even at higher levels of math and science, this formula comes into play quite a bit. All right, you got to know what a direction of 105 degrees 17 minutes means. And Gabe, could you tell me what that means?
That means...
Am I going east, south?
Looks like you're going southeast.
Southeast, I agree with you. So whenever you're given a bearing without a direction in the beginning, I would draw a north ray, because that's where it's going to be referenced from. So there's north, which is 0 degrees. Then you're going 105 degrees clockwise from there. So you're going to pass east and go 15 more degrees. So this is your trajectory. And we're told that it sails for 3 hours at 15 miles per hour. Anyone? How many miles has it gone? Say, what was that? 45. Yep. 15 miles per hour means you go 15 miles every hour. You've traveled for 3 hours. So 15 times 3.
Isn't there like knots or something?
Yes, there are knots. K-N-O-T-S.
How is that? How many miles per hour is that?
I don't know off the top of my head. 40, that's something that's easily found though online. 45 miles. We want to know how far south has it sailed. So let's draw a horizontal line here. And we want to know this distance here, how far south. Voila, a right triangle. Like I said, the diagram is often the hardest part. Okay. Amber, how can I solve for x?
Would you have to figure out what that angle is there? Like
Yes.
between,
And how could you figure that out?
to 105 degrees, 17 minutes minus 90.
Excellent. Because you want to know just how far south it's gone, which is a vertical distance from this east-west line, what you can do is just remove 90 degrees, which would be the angular distance between north and east. Hopefully you can see that this is a 90-degree angle here. From 105.17. Okay, so 15 degrees, 17 minutes is that angle there. And then what can you do?
You can do the sine of that angle.
The sine of that angle, good.
So that's the sine of 15 degrees, 17 minutes equal to x over 45.
X over 45. Opposite over hypotenuse. I agree with the sine choice there. Good. So, back before calculators, people used to have to look these up in a table. No need anymore, plus we can be a lot more precise with these machines. So the sine ratio, the ratio of opposite to hypotenuse in a right triangle that has a 15 degree, 17 minute angle is 0.26 about. Try to keep in mind what these sine or other trig ratios mean. So the ratio of two sides of a triangle. And then to solve for x, you just multiply that by 45. 11.86. They want it to the nearest mile, so 12. There's our answer. The Boat has sailed about 12 miles south. And for those of you who have an interest in physics or who are studying physics or who will be studying physics, as I've said before, trigonometry is the math for you. Any questions on 3? Good? No? Okay. Let me know if you need anything. Hot towel, cup of tea. Joking. The airspeed of an airplane is 620 kilometers per hour, and its angle of climb is 7 degrees 51 minutes. What is its ground speed? Have you ever been in a plane in which, in front of you, there is a screen, and you can choose to see the diagnostics or like the statistics of flight?
How far you are from the
How far you are, and airspeed, and ground speed. Anyway, these things exist. Okay? It depends on the plane. But some planes have them. So how can there be two speeds? Dan. Wind resistance, okay, that's a possibility.
And how fast are you moving compared to being parallel to the ground?
Maybe how fast you're moving being parallel to the ground. Any other suggestions? Yes.
Do you mean like two speeds at the same time? Or
Yeah,
just
an
talking
airplane
about,
can have two speeds at the same time, an airspeed and a ground speed when it's flying.
Because say you're going vertically, you're not moving anywhere compared to the ground.
But you're traveling at some speed through the air.
Yeah.
Yep. So Gabe hit the nail on the head. Ground speed is how fast you're traveling relative to the ground. Like how much ground are you covering? Airspeed is just how fast you're going through the air. And as he said, you could have a 0 ground speed and a very fast airspeed if you're going straight up or at a very steep incline. So you can also use right triangles to analyze situations that involve simply speeds or velocities, which is pretty cool. In physics, you might study vectors. This is what this is all about. Okay, airspeed, speed through the air. We've got an angle of climb. That can help you. So it's like an angle of elevation. So this is how fast we're going through the air. And this is how much ground we're covering per hour. That's your x. And then you get a right triangle. It's amazing how many applications there are of right triangles. The rest is easy. Which trig function, anyone?
Cosine.
Cosine, very good. Cosine is 7 degrees, 51 minutes equals adjacent side over hypotenuse side. 620 cos 7 plus 51/60ths. Our ground speed is 615 kph. So every hour, if this plane maintains this angle of climb, we are going to cover 614 kilometers on the ground. That's what that means. Bless you. Any questions on 4? Good. We're doing a good job. Sorry about that. I thought I selected 2 sides.